Okay, hi guys. So we've got a busy week this week, finishing off all our skills-based stuff and starting to get into our application stuff. So kind of finishing off the achieved stuff this week. So the last of our things we need to learn to differentiate are trig functions. So our trig functions are usually sine, cos and tan, but you'll remember that when we were doing trig, I did talk a little bit about sec, cosec and cot and what they actually are. So remember that cosec is 1 over sine, sec is 1 over cos, cot is 1 over tan. This table here is given to you in the exam, you just have to know how to use it. So when we're differentiating sine, it goes to cos. Cos goes to negative sine, all right? Tan goes to sec squared. Cosec x goes to negative cosec x times cot x. So those x's are the same. Sec x differentiates to sec x tan x. And cot x differentiates to negative cosec squared x. Okay. So there's one other thing that we need to, well, actually, let's have a look at a couple of examples first. So here's the first example. If we've been given y equals 6 cos 5x, all right, there's not very many times that it won't include the chain rule, guys. So you don't usually get to do these because all you have to do is just read the table. So they're not testing whether you can read a table. They're actually wanting to know, do you understand how differentiation works? So dy by dx will equal, now remember what I've talked about, that 6 means 6 of the question, 6 of the answer. So 6 cosine differentiates to negative sine x. Now it's quite important that you put the negative in the right place. So either you're going to put it in a bracket or you're going to put the negative out the front here. You don't put the negative there, otherwise it says 6 minus. So if you've got it in a bracket, it means 6 times negative. If you haven't got it in a bracket, it means 6 times minus. It's wrong. So there's the negative, and sine 5x, that doesn't change, just like in e to the x and ln to the x, that stays the same. Now we have to invoke the chain rule because this is a present, right? So we have to actually differentiate that and multiply by 5. So in essence, we've got this, negative 6 times sine 5x times 5, which would give us negative 30, but we don't need to write it like that. We could just leave it like that. Okay, let's have a look at another one. So this one, y equals 3 tan squared x squared. Okay, now what we have to remember here is the brackets. So there's no bracket here. This is not tan squared x all squared. It's just the x squared. This little squared here is a notational thing. When we put a little squared up there, what we're saying is it's the actual function squared. So we can change this to 3 of tan x squared squared. Okay, not the 3, just the function. Tan x squared squared. And we need to rewrite it like that so we can use our chain rule. So our chain rule says from outside in. So we've got 2 lots of presents again. Here's one, right? And a lot of you are forgetting this one. And this is the second one. All right. So take the power, multiply by it, 6 of the first present, and decrease the power by 1 times. Differentiate the next present, sec squared x squared. Remember to put it in brackets. And now differentiate the last present. I'm going to move that a little bit and put it here because it looks better. All right. So 6 tan x squared, sec squared x squared differentiates the first present, differentiates the second present. All right, and leave it like that. The answers will pretty fired up. We're okay with that. So check my answers that I'm uploading, all right, that your answers are looking the same as mine. So if you're using the EAS book, you're getting the answers in the unsimplified form from my answers. Let's have a look at another one. Y equals 4 sec squared x times 5x squared. Right, so we've got 2 x's here. That means that we've got the product rule, all right, f and g. Now, at this point, I'm going to say, okay, I'm going to leave that 4 and just make it by itself. It's just 4 of those So 4 of the answer. So if we've got f dash is going to be, if f is equal to sec squared x, then f dash, remember that is sec x all squared. All right, so that means the answer is going to be 2 sec x tan x, and differentiating x gives us 1. So that's the chain rule there. And g is 5x squared, so g dash equals 10x. Now we have to put it together. So dy by dx equals f dash g plus g dash f. 2 sec x tan x in brackets times g, 5x squared, plus g dash 10x in brackets times f sec squared x bracket. Now don't forget the 4. So 4 of all of this. All right, and that's the answer. Leave it like that. One more. So we can mix up now all of the things together. So if we've got 1 over e to the x, all right, that looks quite complicated. It's very likely to be the achieved level question because none of that's really difficult if you know how the rules work. So this is so we need to rewrite it first. Remember, we're not allowed x's on the bottom, and this one here needs to be written as well. So we've got cot of. If we rewrite this with a positive power, it's e to the negative x. Cubed. 2 brackets. All right, so bringing that up to the top, it was like if it was 1 over x squared, it would be x to the negative 2. Okay, now presents, presents, presents everywhere. So we've got 1 present. We've got 2 presents. We've got 3 presents. So we've got to go very slowly and undo each at a time. So dy by dx equals, what do we start with? Yep, you're right, Sendel, it's the 3. So 3 bracket cot e to the negative x squared. Next one. I don't know who said that. We'll go with Jess. All right, Jess, you're right. We're going to use the cot one. So we go to the cot rule, put a bracket in, negative cosec squared. And now we need e to the negative x. And then, what do we need next? Next one is this one. How do we differentiate e to the negative x? Good. So we take negative e to the negative x. Remember, e differentiates to itself. So we're just differentiating the power and getting -1. Big, huge, long line, one step at a time, not particularly difficult. So hopefully you'll be able to do those ones pretty straightforward. Watch for these squares, all right? You can't differentiate anything squared. You don't have a formula for it, so you need to change it first of all into one of those. Okay,